Okie dokie, we might make a start then. Thank you everyone for joining us today. My name is Angela Juhas and I'll be your moderator for today's webinar covering skid resistance 101. So some fundamental principles of skid resistance is what we're going to be looking at in some detail today. Our presenter today will be Paul Hillier of ARB Group, so a warm welcome to Paul and thank you for joining us today. Paul is based in ARB's Sydney office and he holds the title of National Technical Leader for Incident Investigation and Strategic Reviews. And I also know that he's very passionate about this subject matter and I'm very certain that's going to come through in his presentation today. For those of you who haven't participated in one of our webinars before, I'm just going to run through a few housekeeping matters with you. And for those of you who have, perhaps a refresher. Our presentation will go for approximately 40 to 50 minutes with about 20 minutes allocated for questions at the end. Now we're going to aim to have the webinar completed in the hour, but we might run over with some question time. Now don't worry too much about taking notes or anything of that nature. We're going to be recording today's webinar and everybody participating today will be sent a link to the presentation along with a PDF version of the materials. And we'll aim to get that out to you over the next few days. Now a few functions of the GoToWebinar system, especially for those of you who haven't participated in a webinar before, we welcome your questions, the more the better. So what we ask you to do is to please type these into the question section of your control panel and that will probably be in the right hand side of your screen. You don't have to wait till the end, although Paul will probably cover most of the questions at the end, possibly during the presentation also. So just type them through. And just to get you all a little bit more familiar with how the system works, if you want to type into your question pane now, perhaps your name and where you're joining us from today, that would be great. And we'll soon be handing over to Paul to start his presentation. So who have we got joining us today? I think I remember quite a few people from all around Australia and New Zealand, in fact. So we've got Rob MacArthur from Adelaide. Thank you, Rod. Tim from HDS Australia. Thank you, Tim. Lots of people from all around the country. Mike Robertson, Chris Cleary from Toowoomba. Wow. Christchurch, New Zealand. We have quite the audience from Sydney, Mike Robertson, Melissa Diaz from ARB Group Melbourne, Lee Hale. Great. Now that I'm very confident that everyone knows how to use the system, I will hand over to Paul to start his presentation. So, Paul, over to you.
Thanks, Angela. Good morning, everybody. Welcome to our webinar, Skid Resistance 101. What we'd like to do to start off with is just to ask you a quick question. What we've done is we've ranked 3 road surface conditions in order, from their lowest to the highest level of grip that they'll provide to a road user. We're giving you a choice of answer A, B or C. So we're looking for an answer from the lowest condition to the highest amount of grip provided to the road user. Is it A, B or C?
Now for those of you who haven't participated in one of our webinars, you should see a screen pop up with your answer options there, and if you could just click the circle next to your answer and click submit, that will bring your results over to us. So I can see about half the people have voted at the moment, so we'll just keep it open for a few more seconds. Paul, what do you anticipate the most popular answer choice for this question might be?
Well, I'm hoping people that think about being a driver at this stage, not to think too much about being a practitioner or an engineer. Perhaps I should have said that before giving people a chance to answer, but I'm hoping for quite a few letter A's, Angela.
Okay, all right, I think we've given that away. Now thank you very much everyone for voting. I'm going to close that poll off and share the results with you. So Paul, what do you think about that? Looks like you got your wish there.
Well, I can't actually view them, Angela. Can you just remind me of the percentages that you got there?
Oh, yes, okay. Well, for answer A, we got 93%, so that was what you were hoping for, and 4% each for answers B and C. So you've certainly got the majority there.
Okay, well that's good because it gives an idea that people have got a basic feel. Please don't worry too much if you click B or C. We'll run through that and why the answer may be A in a second. So let's have a think about why we're here today and our objectives for our webinar. We're trying to give a basic awareness through this. We'll talk about a little bit later about a series of webinars that we'd like to put on, providing some more detail to the skeleton that you'll see today. So we're going to touch on some key terms, some key principles, and please think about a focus on road safety outcomes. That's the way that I like to think about skid resistance, thinking about positive outcomes and saving lives on our roads. You may be wondering why we have the 3rd International Road Surface Friction Conference logo at the bottom of the screen. Well, I was very pleased to be able to host that conference in 2011 on the Gold Coast, and an international conference on skid resistance and safer road surfaces, and indeed the next one in the UK next year in May 2014. I'm going to use some terminology, and I'm going to interchange, or not necessarily consciously, between the words you might hear skid resistance or skidding resistance or sliding resistance and the other terms you see up there. I'm going to be fairly loose about the way that I move between those terms. Now please, strictly, I should probably get a little bit of a slap on the wrist for interchanging between a few of them, but on very technical terms. But basically, let's all think about the grip that's provided by the road surface to the road user. So again, if I interchange between these terms, if you just think about the grip, and we'll get on fine. So, Friction 101, let's go back. I like building things up from first principles and going back to our school days. And probably, hopefully, you all remember the physics class with the wooden blocks sliding down the slope. And what prevents it sliding down is the friction. And a certain amount of heat's generated. Well, that's all very well. That may have been 20, 30, 40 years ago. But for the highways application, it's still valid. We need that grip to enable cars to manoeuvre, to brake, to steer, to accelerate. And what gives us that grip is the friction in the contact patch between the tyre and the road surface. If we don't have the level of grip or the level of friction for the manoeuvre that's being attempted, the tyre can slip. And then we start getting into a chain of events. If the tyre can slip, we might get a skid. If we get a skid, we might get a loss of control, and dare I say it, and unfortunately, we may get a crash scenario on the end of it. So I like to think of skid resistance as being there, something that starts a chain of events, or even prevents a chain of events, probably better to say. And that's why it's so important in terms of our road safety outcomes, that we do what we can as practitioners. Going back to our poll question, we talked about the level of friction in the dry conditions. Unfortunately, for most of the road surfaces that we use, the friction that we generate, that we're able to provide, is at a level that supports most routine manoeuvres, and some not quite so routine, as you can see there. That's a car in a controlled skid test where the brakes have been applied 100% for long. So you can see from that the amount of heat and energy generated between the contact patch between the tyres and the road surface. So in dry conditions, a general rule of thumb, we're pretty much right. But it's when we start thinking about wet conditions or where we have contaminants on the road, we get a level of friction that drops off, and we'll think about why that might be in a moment. But what you're seeing there is a very typical scene, and our experience is showing us that from a dry road to a wet road such as you'll see there, we're pretty much, as a rule of thumb, looking at a reduction in the available skid or the grip of around about 30% in those wet conditions. It's not just about the presence of water, it's about the amount of time that our vehicles take to stop. And I'm going to be a little bit devious here. I was going to show you a video of a skid to stop test in dry conditions and wet conditions, so you could see that extra length. But I'm going to be, as I say, a little bit devious and hold that back for the rest of the webinar series that we've got coming up. So hopefully that might be a bit of a tempter for people to come in and have a look. I've got some film of trucks, I've got some film of motorcycles, which hopefully people will find interesting. But when I would think about water being on the road surface, where we tend to get into problems are scenes like this. Top left, where we have some deformation in the road and we get a slight build-up of water, it can't release and congregates in the wheel path. Similarly with bottom left, that's exactly the same mechanism. We've got some wheel path rutting there and the water forming in quite a small film on the road. And indeed the picture on the right that you've already seen, which is where we have some transition between crossfall and longitudinal crossfall, and we get a stream of water going across the road. And our experience shows that typically this is where we get our accidents in the wet. It's not the scene that I'm going to show you next that tends to cause us the problem. And the reason for this, I guess, is that people can see things like this. And yes, we tend to get some accidents, but pulling or tugging on the steering in such conditions, but not our genuine skid, wet skid type crashes. So when we're thinking of skid resistance, we often call water a contaminant, and for good reason. It reduces the amount of grip that we've got available. But we all know that it's not just water on our network that we need to be careful about. We can have mud, we can have oils, we can have stock effluent in certain parts of the world, and we can just have general detritus. And as you can see on this picture here, we have some general debris from the road, we've got some loose stones on the road, some aggregate from somewhere, and all of these can bring the level of skid resistance, the level of grip down. And hopefully people are thinking ahead a bit, thinking, well, we need to control these situations. We can only do so much with the surfacings that we put down to provide the grip. We also need to think about managing our road network to provide good levels of skid resistance and to make sure it's there at all times. Now, coming back to oils, this can be one of our worst case scenarios, and particularly where we've got a mixture of oil and perhaps water on the surface, a little bit of rain. I've been involved in investigation of cases where in oily conditions we can reduce by about 70 to 80% of the available grip. So as you can imagine, if somebody is trying to steer, brake or accelerate in such conditions, it can be quite a problem. Okay, so as we've seen from those slides, it's a bit more to it than simply being wet, dry or dirty. We also need to think about the vehicle. We also need to think about the driving motion that people are putting in. It's not just about the surfacings. So as good a job as we do, we often find that just the way that people drive, the way that they maintain their vehicles, can influence the end result. And that chain of events that we talked about. The condition of the vehicle in terms of even just the drive of the vehicle, how the wheels are loaded, the tyre characteristics, their width, their depth, how good a condition the tread's in, are they a bald or a treaded tyre? What sort of speed are people driving at? Are they trying to accelerate or decelerate? All these things will have an influence. You can see there on the left-hand side how the road surface contributes, and we'll touch upon the materials that are involved and these two terms there, macro and microtexture, in a moment. Talking about the conditions, as we've seen, dry, wet, winter, slippery mud, and also things like the amount of bitumen that might be on the surface, and indeed perhaps the temperature. So all of these things contribute, and all of these things are important. And we often get criticised as practitioners for what we try and do and how we go about it, but we need to be quite pragmatic in some of these loss of control skidding crashes and think about what the driver's done. Think about what's contributed to the final outcome that we get. Let's have a think about tyres. And this will hopefully hit home to people about how we need to keep our cars in good condition. what you're seeing here is you're looking up through a glass road surface. The yellow liquid is actually water. It's had some dye put in it so that you can see what's happening. You have the direction of travel of the car illustrated there. And as you can see, this is with a treaded tyre, forcing the water. It's forcing it out sideways and forwards so that you get a contact patch between the road and the tyre. And you can see from the black colour there that it's quite intense. The colour of the contact is showing you that it's quite an intense contact. So that's the treaded tyre, and that's how it's supposed to happen. That's how we're supposed to operate, and the tyre gives us some good benefits. But let's compare that with a ball tyre. Here you'll see a ball tyre, also the same direction of travel. Yellow water there, exactly the same. But you can see that with a ball tyre, the mechanism of removing the water is very, very different. And it's certainly not as efficient. What's actually happening is the ball tyre is struggling to get rid of the amount of water there. The contact patch becomes a lot smaller. The contact patch is a lot less intense. So the level of grip we get is much reduced. Basically, the mechanism for the tyre there is just bow waving the water out of the way. And as you can see, it doesn't necessarily do the best job. It certainly doesn't give us the conditions that we had before with the treaded tyre. We talked about wheels, but let's not forget we have lots of different vehicles working or manoeuvring on our networks. It's quite sobering sometimes to think about, as car drivers, the only thing that keeps us on the road is that contact patch between 4 tyres and the road surface. And it's quite a small area when you think about it. But we also have to think about our two-wheeled friends. We have a motorbike there in the picture, but similarly it could be a cyclist that we have in an urban area or indeed a rural area. The contact patch on motorcycles and two-wheeled vehicles is much reduced. So we need to think about these road user types quite significantly when we talk about skid resistance. Okay, let's see how we're travelling. Let's have a little bit of a break. Angela, have we had any questions so far?
At the moment, we're still waiting on a few more questions to come through. But just while we do wait for some to come through, I was a bit amazed by that picture before about the ball tyre and really what a difference it actually makes to have tyres with good tread. I'm about to head out to the parking lot and have a look at my own car tyres and get them changed over really soon, I think. So they're fundamental to safety, aren't they?
Absolutely, to give yourself the maximum chance to get that contact between the road surface and the tyre. And often we get frustrated when we get involved in court cases sometimes as road authorities and we find out that vehicles, the tyres are less than good condition. Now, hopefully, and more often than not, that gets taken into account in the overall scope of things when people are determining fault or levels of compensation and various things. So it's not unnoticed, but often not given the credence that it perhaps should, in my opinion.
Yeah, definitely. Paul, we do have a question that's come through from Mike Darnell. Thank you, Mike. The question is, did you say 30% reduction in friction when the road is wet?
Yeah, it's a very general rule of thumb. You know, it could be 10%, could be 15 on certain roads, could be 20, but studies have shown and documented around about 30% is a good figure to have in your mind. So that's why I'll give the game away a little bit, but that's why we measure our skid resistance in the wet to give us our worst case scenario.
Thank you for your question, Mike. And Paul, I reckon we can probably move on then.
Okay, so hopefully we're travelling okay. So let's think about the skid resistance provided by road surface, something that we can hopefully influence in the way that we manage and maintain our network and the way that we specify our materials. So this is where I'm going to talk about the term skid resistance in a little bit of detail. It's basically a manufactured term. It's been developed to for us to understand the contribution of the road surface alone to the level of grip or friction available. We're trying to isolate that contribution of the road surface. Now, it would be fantastic if we just had to think about the term skid resistance, but unfortunately we've got a bit more to do than that. We found out that there are two components to skid resistance. There's a microtexture component and a macrotexture component, and we'll describe each one of those in turn. Just have a quick look at that diagram before we change onto the slides. The microtexture component is the one on the left, as you can see ringed there, and then a macrotexture component. So, what are they? The microtexture is the individual structure of the aggregate particles. And what it does for us is it gives us what we call adhesion between the tyre and the road surface. It's very effective at lower speeds. It's very effective at lower speeds. It enables us to manoeuvre. But the microtexture of the aggregate is gradually polished away by the action of traffic, and especially in the wheel pass, as you can imagine. Where you don't have any traffic, we tend not to lose the microtexture. There might be a bit of weathering, but we're talking about where the action of the traffic is. And it tends to what we call an equilibrium value. Once it's polished, it's polished. What you're seeing at the bottom there is some microscopic pictures of an individual aggregate particle. On the left, it shows an unpolished piece of aggregate. And hopefully you can see there that it's quite rough. It's got quite an amount of microtexture to it. And that comes from the aggregate geology, what it's made up of, the minerals that it's made up of. Once it gets trafficked, it starts to polish, and as you can see on the right there, that's the microscopic picture of the polished state. And the rate at which it gets from the picture on the left to the picture on the right is determined by the traffic, the volumes and the type of traffic. What does it look like in practice? Well, let's have a look at these pictures. Here's some examples of polishing. Top left, you'll see the very early days, starting to show some signs of abrasion and wear of the top surfaces of the aggregate. Moving into the middle, that's a concrete road that's starting to get some of the exposed aggregate surfaces are starting to polish up. Moving along to the bottom, that's a picture I took in a European country where there's a lot of polishing of the aggregate, and we put some water on that to make it look up as particularly shiny on the photographs. So as you can imagine, what we're getting out of our microtexture in that picture on the bottom right is a fair bit reduced. We're not getting those levels of adhesion, which then means that the wheel, the tyre, is going to slip across the surface. But remember, we're not just talking about the microtexture. We also have what we call our macrotexture component. You may have also heard it called texture depth or surface texture. And our macrotexture is made by the valleys and pits between the individual aggregate particles for blacktop surfaces. If we have concrete surfaces, we actually induce or make our macrotexture by putting grooves in the surface. What happens with the macrotexture is that it actually deforms the shape of the tyre, and that enables some of the force, some of the heat, some of the friction to dissipate. We get what we call hysteresis occur between the tyre and the road surface. And that has a great effect in enabling us to grip and stop and manoeuvre at higher speeds. Again, a rule of thumb for you, and please just have this in mind, we're talking at speeds of around about 75, 80 kilometres an hour and above. We are extremely reliant on macrotexture, so on our higher speed roads. Macrotexture is also important for us because it helps remove surface water. The water can run between or run in the valleys of the surface. It also helps with spray and noise reduction as well, so it can be a good thing for us in a number of ways. Let's see what happens when we start to lose macrotexture. Well, that's when we get our things that we call flushing, bleeding, fatting up in some jurisdictions. And top left you see a bituminous surface there that's starting to show signs of flushing or bleeding. There's some excess bitumen in, and it's working its way to the surface in the wheel paths. We move across to the picture on the top right, and we're starting to get some quite bad flushing or bleeding. There's a lot of bitumen in the surface, and as you can see from the pictures at the bottom of the screen, it's starting to fill up the macrotexture. It's also starting to mask the microtexture, and you can particularly see that on the picture on the bottom left. You can see that the excess bitumen has filled in a lot of the valleys, and also a lot of the microtexture of the stone. That bubble you see there is just a water bubble in the surface, and that was a classic picture in a hot day, a close-up picture there. So, our two components to skid resistance. We need to think about the microtexture, and we also need to think about the macrotexture, or our surface texture as we often call it. High stress locations, where we have lots of braking or turning manoeuvres, we get our greatest decreases in skid resistance. The microtexture tends to polish out very, very quickly, where we've got lots of braking, lots of turning, and particularly where we have some very heavy goods vehicles, like this one from up around the rural Queensland area, working the mines up around Cloncurry. What's that, 8 trailers there, and you can imagine going around some quite rural roads, turning into intersections and various things. There's going to be a lot of polishing, a lot of wheels to contact the road. So our high stress locations are important that we identify where they are. Now I've got another question for you. We talked about the wheel paths of our roads. If the skid resistance level is higher in one than the other, do you think this could be significant?
Great question, Paul. Well, I've just
what do you think, Angela?
Oh gosh, I don't know. I'm certainly not qualified. No, I don't know. I think I'm going to wait for some answers to come through and copy those perhaps. So we've had about 60–70% of votes, so just a couple more seconds if everyone can click their answer through and just hit submit. That will come through at our end. Alrighty, so I might just close that off for the minute. So Paul, what we actually have, and I'll share that with the audience at the moment, is we have 93% of people answered yes and 7% answered no. So what do those results say to you?
Well, again, very encouraging. I can understand why people may have put no. I would imagine that there may be some thinking about anti-lock braking systems on cars, or there may be some people, which I'll touch upon in a moment, who are really in touch with the research on what we call differential skid resistance. So let me talk a little bit more about that. But well done to the people that said yes, and well done to the people that said no. And let me explain why you can have a foot in each camp, I guess. We get differential skid resistance or we can have it for a number of different reasons. It can be created by different surfacings. We might have some haunching or some trenching in the road. It can be different rates of wear. We can have local repairs. It could even be a differential friction provided by the road environment. For those people down in Melbourne, for example, it's not unusual to drive with one wheel on the black stuff and one wheel on a tram track, and we try and avoid that if we possibly can. Now, just so that you don't think I'm mad when I said the answer could be yes or no, well, the jury's out on this a little bit in terms of how significant it is in straight line braking. Some people say yes, it's all about straight line braking, and others say, well, no, it's got to do with cornering, and it's more influential on cornering. And unfortunately, it's one of those ones where the jury is still out. As I said, there's research going on. And you may have even been thinking, well, with ABS systems on cars, does it make a difference anyway with new vehicle technology? Surely the ABS system and ESC and various things will cope with differential skid resistance. Well, the answer to that is maybe. ABS systems have got to be deployed properly in the first place. You've got to know how to use them effectively. But also we need to bear in mind that the average age of car fleet in Australia is 9 years. There are an awful lot of cars out there that don't have ABS systems fitted. So in terms of our role as a highway authority with our duty of care, it's certainly not time to put the queue in the rack just yet. Some road authorities are particularly interested in differential skid resistance. They measure it and they've developed some guides and thresholds on it. But so you can visualise it, let's see it in action. And in an extreme case, what you're going to see is a controlled test on a racetrack. You'll see there's a road surface where the half of the path of the vehicle, they've put down a mat and they've put down some detergent and some liquid down on there to create a very low level of grip. You'll see the car tested first of all without ABS and then with ABS.
Sorry, Paul, just before we go on to your
reminder.
Whoops, sorry, Paul. Sorry to cut you off. Just before you go on to your video, we've had a question come through from Mike Robertson. I wanted to ask you. Truck tyres are much harder rubber. How much difference does this make to skid resistance for the same road surface?
The main difference is the number of contact patches. Sorry if that sounds a strange answer. The number of the area of the combined area of the contact patch is the determining factor. Yes, there are some nuances to do with the compound of the tyre, but fundamentally with trucks we're talking about a lot more mass to keep us on the road and also a greater area. So yeah, so those are the determining factors more so than the compound on the tyres, in my opinion.
Fabulous. Well, mate, we might get onto that video then.
Okay, well let's see the video. The first one, as I say, you'll see without ABS. They've disabled it on the vehicle, and the next one is with ABS. So even if it serves as a good reminder of the importance of ABS systems, well, let's have a look. I'll go quiet for a little while. I won't talk over the video, but let's have a look. Okay, so there's our video. As you can see there, yes, a stage situation. The differential friction may not be obviously quite as large on our normal road environment, but shows you what can happen if you get some yawing involved in the vehicle. Don't forget we often have cross falls and various things on the road surface as well, which will have an impact on that. Our road isn't dead flat all the time. So that takes us through a few more of the principles. Just give people a chance to take a breath and before we move on. Angela, is there any more questions come up?
Great.
Or would people like to see the video again perhaps?
Well, we do have a question come through from Tariq. The question is there any effect of vehicle load on skid resistance? I mean in terms of heavy vehicles, goods carrying.
Yeah, again, it's a matter of how the load is deployed and its influence on things like the centre of gravity, how it's secured, etc. I'm not a huge vehicle dynamics expert. I must confess I'm more on the road surfaces side of things, but certainly when you start getting into advanced vehicle dynamics, you start thinking about the loading of vehicles and how they're loaded and the configurations, what masses, etc. will come into it. Just if we cast our mind back to the block sliding down, the mass of the block is obviously affected by gravity as well as it slides down. And indeed, when we come on to testing in a moment, a measurement, we'll talk about a loaded tyre and how we measure the skid resistance with a loaded tyre.
Ah, fabulous. Okay, Paul, we do have another question. It's a great one from Rosie in Melbourne. The question is, Paul, do you think there should be some simple skid resistance training for our young learner drivers?
Absolutely. Yes, please, and I would be happily do it tomorrow. I think it's absolutely essential. My preference would be to actually for people to witness it firsthand. I tell you for why, not just from a perspective of going somewhere safe and doing some tests and people a bit of wow factor, but we did the same thing at the friction conference we mentioned in May 2011 out of the Gold Coast. We did some testing at Mount Cotton, thanks to Transport Main Roads, and the engineers that saw it, all drivers or fundamentally drivers as well, came back and just said it was fantastic actually seeing it in action and what difference things like wet roads make to stopping distances, how brakes work, how the variation in speed and what difference that makes to stopping distance, and et cetera, et cetera. So yeah, absolutely, I'd be a huge advocate of it.
Yeah, I think with young people especially, they need to see it to believe it. Sometimes being told something, it just doesn't click, you don't absorb it. When you actually see it, that's what makes all the difference, I think. So you're too right. We do have another question come through from Christopher Cleary. We might just answer that one and then perhaps we'll move on with the presentation.
Just before you mention that, Angela, one of the things that people often see as well when they're watching a skid test is the amount of energy involved, and particularly the heat. Particularly when you do it on a dry road surface, that's often the sobering one for people as well. They see that there's so much energy involved, particularly when we're going at high speeds on dry roads.
Fabulous. All right, well, the question from Christopher, and this is actually one that really interests me as well. There is a trend to larger diameter and lower profile tyres on modern cars. Do either or both of these factors have any influence on skid performance? And the reason why I'm interested is because I do have low profile tyres on my car. So, Paul.
Yes, they do, and particularly with, again, sorry, it's going to be a plug for our webinar series, but we'll talk about aquaplaning there. We haven't got time to touch it, but the profile of the tyres and how tyres are inflated absolutely will have an effect on that tyre road interface. So I guess it's really for me to give a sort of bit of an infomercial. If you want to find out more, have a think about the webinar series that we'll talk about at the end. But yes, the simple answer is yes, absolutely has a big effect.
Excellent. Well, thank you very much for your questions. And Paul, we might move on with the presentation then. Thanks.
Okay. Well, we're going to move on to measurement. We've talked about many of the factors that determine the amount of grip, and if we want to just isolate the road surface, as we talked about, we have to think about doing things like controlling the amount of water we put down, the test tyre, the speed that we take our test results from, and the equipment that we use, its calibration, etc. So just as if we were testing any other condition parameter or any other parameter or any other test we're doing, we can control to isolate the road surface, to enable us to compare sections of road surface. We'll talk about some of the machines that were available to measure what we call skid resistance in a second. But one of the big things to get across to people is that the measurements we take are just a snapshot in time. When our test machine goes over the road surface, the value that we get is truly only applicable for that moment in time, with that particular vehicle, with that vehicle in its state of calibration, and for the path that it went. Okay, did it hit the wheel path? Did it slightly miss it? Can all be extremely important in the value that we get. A little bit more about that in a second. Unfortunately, or well, perhaps not the words unfortunately, but we have to contend with the fact that there are a number of devices that have been developed, a number of techniques to measure this thing that we call skid resistance. You can see from the number of blue squares there on the diagram, there's at least, well, there's 8 there, and there's a few more devices that aren't in this particular diagram at the moment. So there are a lot of devices that measure what we call skid resistance. Now, depending on how they've been established and exactly what they do and exactly the way they measure, they all give us a slightly different output. Now, that might sound to some people that we really don't know what we're doing, or we haven't really mastered this. Well, it's actually not the case, but it's measuring things slightly differently. We get a slightly different result, and we need to be aware of that, particularly if you're working for a road authority that might use 3 or 4 different devices to measure skid resistance. What we get from each machine is an output, depending on from which one. Can be a figure like an integer like 0.45, or an integer like 45, or a decimal like 0.45, for example. So the actual outputs themselves, you need to be careful. As you can imagine, as there are a number of different devices that measure skid resistance, people are trying to compare them. They try and come up with correlation equations, and we need to be very, very careful with that. What I would say is I don't want people to go away thinking, well, why do we bother with this? If they can't get the machines to measure the same thing, why are we bothering here? Well, it's certainly better to measure, in my opinion, than not to measure it, than to rely on perhaps visually looking at a surface, or rubbing your hand over it, or indeed doing the engineer's boot test to establish whether something is slippery or not. Now, yes, of course, all of those things, rubbing our hand and rubbing our foot on the surface, we can say absolute values, but it doesn't give us a number that we can use to compare road surfaces. And that's why skid resistance has been developed, the equipment has been developed. It enables us to compare lengths of road, to then prioritise them, to say which ones are we going to look at to see whether there might be some remedial action that's needed. It helps us with things like our resurfacing programs and our road safety programs that we do. So this is where we have people who will adopt a network approach. They'll do routine measurement every year or every 2 or 3 years on a particular road network to enable them to compare road surfaces, to enable us to get trends. Is the skid resistance of the location going up or going down? The other thing that we can do with our skid resistance equipment is that we can do spot measurements or react to crashes that have occurred. So it's not just about our routine management of a network. We might want to do an investigation of a site. We might want to respond to a crash and provide some skid resistance data for the inquiry, for example. So a couple of approaches there. As I mentioned earlier, macrotexture is our key determinant of high speeds. So what we tend to do, and what we've built into the habit of doing, is to collect macrotexture data as well as measure skid resistance, this thing that we call skid resistance. And we look at the 2 survey results side by side. The sites that we're particularly interested in are the ones where we get low levels of skid resistance and low levels of texture combined at the same site. So let's have a look at the devices, what they might look like. We're only going to have time to cover 2. Again, a plug for the webinar series though, we'll look at a number of the different devices. The grandfather of them all, the British Pendulum tester, or the portable skid resistance tester as it says there, or the portable pendulum tester. It's got 3 names that I'm aware of, maybe some more around. It is effectively an attempt to standardise an engineer's boot test. It has a slider which makes contact with the ground, and then a pointer that you can see with the numbered scale there, which shows you or gives you an indication of the level of friction. It is controlled in certain ways. The rubber's controlled, the weight of the head, how far it swings, the contact distance on the ground, and also we put water down on the road surface to test it. And this is very good for testing individual spots or after collisions. Here it is in action. Here's Max from New Zealand. Max does a lot of these tests, and you can see he's just about let the pendulum go and he's going to catch it as it comes back. It's pushed his pointer up to the point where it gives him a reading of the skid resistance of the road. You can see the white marks there in the picture. They're marking out where the wheel path is. This is in a particular trial. We were trying to get the results from the wheel path. And as you can imagine, you need a certain amount of traffic management. You need to make sure the operator is safe, etc. So in terms of a network level tool, possibly not the best one you could choose. Leads us along to the sort of machine that you would use on a network level, and this one's called a SCRIM, Sideways Coefficient Routine Investigation Machine, SCRIM for short. Basically, it houses test wheels, and these you can see halfway along the vehicle in the yellow cabinet that's open there, and a similar one on the other side of the vehicle in the right-hand wheel path. And it's effectively a water tanker on a truck chassis, and it deploys the water in front of the test wheel. The test wheel has got a load on it, and it's got sensors on it, and it works out the friction that you get from the road surface. The test tyres are smooth in this particular vehicle, and they are representative of a motorcycle tyre from the original development days of this particular bit of equipment. A few bits and pieces to perhaps note. It has the yellow and amber beacons on there for safety as it goes along the network, testing at either 50 kilometres an hour or 80 kilometres an hour, depending on which jurisdiction. And it also has, you can see just behind the cab, some GPS systems and various things there to help linear reference and geolocate the results. So a modern bit of kit, and this is very applicable to doing a network level test. It's not the only piece of equipment, but one which is favoured by a number of road authorities. Here you can see on the next picture we have a close-up of the test wheel. The blue nozzle that you can see on the left is applying the water to the road surface in a controlled manner, and you can see the weight loading can go onto the test wheel. And as you can imagine, the test wheels take a bit of a hammering, and those are only good for a certain number of kilometres before they're replaced. And as you can see, we carry spares on the vehicle. The value of skid resistance is recorded continually and goes into a computer on the front of the truck. So there's a couple of the main devices, and as I say, there are many more which we can talk about another time. Another question. So far we talked about skid resistance. Do you think we can measure the skid resistance of an unsealed road? Yes or no?
Great question, Paul. Well, I've launched that now, so if everyone could just click whichever answer they would like to submit, we'll get those through at our end and see what the majority of people are answering yes so far. So 67% of people have answered yes so far. And I might just wait a couple more seconds for everyone to get their votes in, and then we'll close that off. Alrighty, I'll close that off now. Okay, so I'll share the results with our audience today, and we have 66% of people answered yes to the question, 34% said no. So what is the answer, Paul? I'm sure everyone would be keen to know.
Well, again, a bit of a spread and answer on that one. Depends about which term you're going to use to talk about skid resistance on this one. Routinely, the machines that we've shown there, the Pendulum and the SCRIM, you wouldn't use on an unsealed road surface. Devices that people might have heard of called a accelerometer or a dynamometer, of which one brand name might be the term Vericom, people might have heard of. You can actually get some measurements of the coefficient of friction on unsealed roads, and we're looking at that a bit more as we go along. So not typically, particularly if you're doing network level testing, you'll stick to blacktop and concrete roads and spray sealed type roads, but not typically unsealed roads. But that's not to say we can't do it. Okay, that's the measurement of what we call skid resistance. We're going to have a little look at the measurement of our macrotexture. As I mentioned, we look at them as brother and sister measurements, if you like. Our macrotexture, the most common test that certainly traditional test would be to do a sand circle or a sand patch, where you come up with a measurement of the texture depth in millimeters using a known amount of volume of sand. You spread it out into a circular patch, and then you measure a number of diameters there, and you can use a formula to work out the texture depth or an average texture depth. So, as we mentioned, very important in high-speed conditions, and because again this can be quite a time-consuming test, and we need to think about traffic management, etc., a number of machines have been developed to measure or continuously measure the macrotexture. And here you can see one of on the left, the white vehicle is one of our network survey vehicles, and on the front of that you can see what looks like an upturned bench. Now that contains a number of lasers, and they fire the lasers down into the road surface, it reflects back up, and from that can give you some measures of the texture depth or macrotexture, whichever one you want to call it. On the right hand side is one of the SCRIM machines that you've seen earlier, and that too has a macrotexture measurement device in terms of lasers put on the front of it. So that machine there will go along, it will collect the macrotexture measurement first, and then collect the skid resistance measurement just afterwards on the wet road surface, and will give you both results from one survey. So it can be quite useful to collect those things at the same time, or quite an efficient way of doing it. Okay, I know we're getting a little bit tight for time, but are there any questions, Angela, any quick questions at the moment?
Look, at the moment we've actually had a few inquiries regarding the upcoming skid resistance webinar series, but Paul, if you're going to get to probably what's going to be covered in that series later on in the presentation, should I just hold off till then, or would you like to?
Yeah, good. We'll quickly run through that. I've got one section left, which is about talking on measuring and managing a network for skids. So we better cover that off, and then we can we need to wrap up things and provide some more information. The underlying principle that we use is based on a series of facts. The first fact is that there's rarely a single causation factor in crashes. There are always multi-factor events. The road surface alone isn't the cause or a contributing factor, the only cause of crashes. There are lots of other things going on in terms of the road environment, the vehicle, etc., people's behaviour, how they react, etc., etc. But what we do know is that, as I mentioned earlier, where we have low skid and low texture, we get problems. And what we also know is, on those particular sites, if we go back and treat them to improve the skid resistance, or to treat them in some other way, such as warning signs or improving line markings, etc., in combination with surfacing treatments, our crash rates fall off very, very rapidly. It's a very efficient way of dealing with safety problems that we have at particular sites. Now, as you can imagine though, and hopefully you've seen a bit of the measurement and a bit of the theory behind it, it is extremely difficult for us to define safe and hazardous levels of skid resistance. As much as people want it to be black and white, we can't do it. We can't say that there's a level where on a particular site cars are going to run off the side of the road in ever-decreasing numbers from next Thursday. It's not that exact a science. It depends on the path people take, the vehicles. There's so many variables. So what we tend to do is we work on a principle of investigatory levels, and we compare lengths of road rather than having what we might call an intervention level, where we would get to a certain value and we would straight away go out and do something. We tend to work more in the field of investigation. It gives us some data to identify the sites that we go out and have a further look at. Well, why don't we just provide a uniform high level of skid resistance on the network? Well, okay, that could be an answer that somebody would come up with, but unfortunately it's a nice idea, but we don't have the resources to do it. We don't have the resources in terms of money, in terms of resurfacing lots of places early. We don't have the aggregates and materials available, unfortunately. So what we have done is that we try and equalise our crash risk across the network. And that's just a very grand way of saying we'll provide an appropriate level of skid resistance at all locations. As many of you will know, our freeways and our straight pieces of road, our high-speed roads, are designed well, they're built very well, and they're often our safest pieces of road. So we can have a relatively low value of skid resistance on those type roads. Macrotexture becomes very, very important on those roads. But we need to have our highest levels of skid resistance where there's high demand. People are braking at intersections, they're steering around tight curves, they're coming on the approaches to traffic signals. And that's where we tend to focus our efforts in terms of skid resistance. Now I mentioned about a point where we might want to go out and investigate a particular site. Here you'll see the values that are used historically in New South Wales and Victoria. They test with a SCRIM machine, and the SCRIM machine is used at 50 kilometres an hour or 20 kilometres an hour on some very tight sites down there which you need to take at a lower speed. You'll see down the left-hand side 7 site categories. But if you look at site categories 1 and 6, for example, and follow them across, these are our highest stress sites. These are where we need our highest levels of skid resistance. Traffic light controlled intersections, pedestrian school crossings, railway level crossings, roundabout approaches. For primary roads, we're looking at an investigatory level of 0.55 measured by the SCRIM device at 50 kilometres an hour. Curves with a tight radius, we're looking at even greater demand, 0.6. So we must provide good quality road surfaces and aggregates and maintain them as such. As you're looking down the list, we get less demand. For intersections, still very, very high. Manoeuvre-free areas, we start to get slightly lesser values. And then divided roads, as I mentioned, some of our safer roads, slightly lesser values of skid resistance needed in our risk management approach or our equalising approach. And this is what's typically done to measure or manage a network. Here it is in flowchart terms. We will cover this in a lot more detail in the next series, but it's about identifying some roads to test, getting the data, and looking at how that data compares to the investigatory level. And going down further, that will help us to make a decision as to whether we conduct more investigation and ultimately whether we need to put some remedial measures in place. As I mentioned, we're lack of time today, but we can certainly go through that and how people will put that together in detail in one of our next sessions. I just want to come towards a close by looking at the management of skid resistance at the moment, some of the dilemmas that we have. It is a hard subject to get across. It is quite a hard subject to think about if you've got other demands and managing an entire network. We have, as it's shown on the top left there, a lot of roads where we have flushing and bleeding of spray seal surfaces. And we're struggling in a lot of cases to manage this and come up with solutions. We're often very good at putting up slippery when wet signs, and we have a proliferation of these around the country, and they often stay up for a considerable amount of time without us perhaps solving the root cause. We're also, as the diagram indicates on the right-hand side, or the picture there, we're quite keyed into skid resistance values driving a resurfacing program. But as I mentioned earlier, it's not just about that. It's about more than just resurfacing. It's about managing things like our crack sealing, as you can see top left. It's about managing our road markings that we put down, top right. Loose aggregate on the road surface. It's about how we use signs on the bottom right there. So it's not just about new surfacings. It's not just about maintenance of our existing surfacings. It's the way that we manage roads. What can we do for our rapidly fatting up, bleeding spray seal? Well, we can do some mechanical means to try and remove the excess bitumen. You can see on the left-hand side of the pictures there. On the right-hand side is some high-pressure water jetting that people are using, where it's trying to remove the excess bitumen to restore the macrotexture and also trying to remove some of that blinding that you've got on the microtexture from the excess bitumen. Okay. Any final questions before I wrap things up?
Look, we've had a few more regarding the upcoming webinar series and also the content that will be covered. So maybe if you could just let us know quickly what will be covered in those webinars. Glenn Heaton would like to know if unsealed roads specifically will be covered in that series.
Yep. Well, whilst we have a good idea of the areas that we want to cover, so a little bit more background on the key concepts, a little bit more on measurement, certainly helping people to put that management strategy together and how to use things like signs. We would also like to introduce people to a lot of the national and international guidance that's out there. I don't want people to think they're all alone with this. There's some excellent guidance documents out there. But in terms of unsealed roads, we can really take it where people want it to go. We're able to provide some content on unsealed roads if there's a demand for it. And so that's the basic answer, I guess.
Fabulous. That's great. Look, we do have a few more questions. I don't think we're going to, unfortunately, be able to get through all of those today. But, Paul, what I might get you to do is just pop up the slide that has your contact details on it. If anyone would like to get in touch with you after the presentation to maybe have a chat about any of these things, that would be fine with you, I presume?
That would be absolutely fine. No problems at all. I'm very happy to receive emails, probably the best way to get me. But similarly, you can see there's my office phone number there. There's the ARB website as well, where you can pick up some more information on what we do on skid resistance. Very, very happy to do that. I don't see today as the end of the story. If people want to discuss issues, then that. And also, if there's any additional questions, I can go through and provide a response to those as well. So I'll make sure I've got the questions and make sure that we have those.
Fabulous. And we do have a record of all of the questions asked today, so anything that unfortunately we haven't been able to answer due to time constraints, we'll certainly be in touch with those people and encourage them to contact us also. Now, just a reminder that the webinar today has been recorded, so we will be sending out a link through which you can download the webinar presentation today. And we'll also be sending out a PDF version of the materials, so all of the presentation material. So I hope you haven't been scribbling down notes. Everything will be sent out to you later. And as Paul mentioned, if you'd like more information, perhaps about the upcoming webinar series or about the subject matter generally, please don't hesitate to contact us anytime. Our contact details are up again there on the screen for you, but we will be sending those out separately to you anyway. So thank you very much, firstly to you, Paul, for presenting today. We're really grateful to have you with us, and of course for everyone who's joined us today. for our Skid Resistance 101 webinar. We hope you'll be able to join us for the series as well. And Paul, if there's anything you'd like to add, just in closing words?
I just want to thank people for their participation today. It's been great to have so many questions and some queries as we've been going along. It is a subject where we can have lots of discussion and lots of debate. While there's lots of research out there, I said the jury's still out on a number of issues, and we need to learn together. We need to learn from people's experiences and share those experiences and get innovative and improve the way that we manage this. So it's part of a long journey.
Fabulous. Okay, well, thanks again, and that concludes our webinar. We hope you can join us for the next one. The details of those are up on our ARB website. Thanks again. Bye-bye.